Introduction to Lab Safety course. This by no means will make you proficient in any laboratory here, except maybe the computer laboratories, because we cover basic things like fire safety and where chemical safety kits are kept and stuff. But in terms of working day to day in a wet lab, this is not your training ground. You will get that training in the lab itself. Okay? So as you've guessed, I'm Colleen, and I've been a member of the safety committee here since I joined in CDS about almost 5 years ago now. But the committee includes Ranjit, who's head of our lab support team, as well as Vatsala, who is our faculty representative to our committee. If you ever need to contact us, just write to safety, and you will reach the whole committee. So today's talk is going to be organized briefly with some campus information, some general laboratory safety, chemical safety, punctuated. What do you need? Nah, I don't need it. By a 10-minute movie, some biological safety discussion, and an introduction to what our instrumentation team does and our lab support team, followed by the exam. On our campus, no smoking is allowed anywhere. You have to step outside to do your smoking. We have campus security 24/7, posted pretty much anywhere you are on our campus. You should be an eyeshot of our security. When you enter the gate, be respectful, show them your ID card, sign in, follow the rules. If you have a guest, they have to register. And they are our first fire responders. And they also provide us with a demonstration and training on how our 5 different fire extinguishers on campus works. So in the event of a fire, please remain calm and tell other people, but don't get hysterical. Assist anybody who needs help to get to safety, and call reception's emergency only numbers, 6666, emergencies only. If it's a small fire, you can use the correct fire extinguisher or even the fire blanket, which I'm going to show to you. If it's a large fire, obviously, get out of the building and take everyone else with you. If you have time, close the windows and doors, but if it's a big fire, your safety comes first. There are fire alarms. We all, depending on which building you are in, have places where to meet during a fire. You meet there, and then you'll get the all clear, telling you when you can come back. Each quarter or so, our security team will provide a fire extinguisher demonstration to us. We request that you all attend this at least once, so that you know which of the 5 to use in the event of a fire. Make sure in your own laboratory that you locate where your fire extinguishers are located, because it's going to be different. If you and or a small number of people are involved with a fire, a small on your lab bench, please, I want you to feel this blanket. I want you to see how heavy it is. The blanket works by protecting you from the fire by eliminating the oxygen component of the fire. So feel its heaviness. Know where your fire blanket. Every laboratory has a fire blanket. General health, we have a medical center here. You can see them on our intranet. You can contact them directly at the medical. They have hours with 2 doctors that share this shift 6 days a week. You do not require an appointment to go see our medical campus doctors. You just walk in and you wait your turn if there's anybody there. But usually you just go right in to see the doctor. We have a physiotherapist also, and she makes appointments in the afternoon only. So because her appointments are more like 30 minutes, you do need an appointment with her. We also offer counseling services on our campus, and you can reach our counselor at this number. And like I'm going to remind you a few times, the emergency only number is 6666. You can also contact reception directly. You all know how wonderful our reception desk is. But in an emergency, 6666. Our physiotherapist sees way too many of you for preventable reasons. So as a result, she said, please remind them. What most of us, I think, do is we do not sit and or stand correctly when we're looking at our computer screens. It's really important that you just keep yourself in line. Don't be looking down or up at your screen, but level. no matter how you're working on it. Also, when you're in the microscope, keep that in mind, that you should be sitting properly and not hunching yourself over or stretching too high. You really want to keep yourself injury-free in your upper body and avoid our physiotherapists. Make sure that when you pick up boxes that you're using your legs and not your back. General lab safety. No running or jumping. You may not talk on your cell phone in the laboratory area. It's fine at your desk, but not where the research takes place. You may not eat or drink. You cannot mouth pipette. You may not store food and beverage in the cold room. And the safety committee thanks you when you do, because we take that. Clothing. If you're working in a wet lab, which I know all of you are not, but when you are, please protect yourself wearing lab coats, closed-toed shoes, pants, and full-length shirts, and so that you're better protected. Do not wear socks with your sandals, because if you were to spill acid, for example, that sock just is like a sponge holding it right there next to your foot. And first you remove your sandal, and then you remove that wet sock before you can treat your foot and get help. So don't do that. If it's cold, wear a closed-toed shoe. All labs will have eye washes, first aid kits, fire blankets, a hard copy of the material safety data sheets, as well as a contact list and fire extinguishers. It's your responsibility to locate those. When you work in the southern labs, Bhumika, who has joined us here today, you want to just like show people? She's the lab manager of the whole building, and she can provide you some orientation to how the eye wash works. The safety showers. Has anyone noticed the safety showers here in the southern labs? Where are they? In the washroom? No, they're on the southern corridor. They're outside of the laboratory itself on the south corridor. They're in the washroom in the eastern labs, but not here in the southern labs. So that's why whenever you're in a working environment, locate your safety equipment. If you are going to use a vacuum, inspect your glassware to make sure that it's safe, looking for some cracks and stars, because if you were to pull a vacuum, that glassware will break on you and potentially cause damage to you as well as the glass that's behind. When you handle all glassware, you should inspect all of it, because if it has some fractures, it's vulnerable to breaking. You don't want to lose your samples. Don't overfill anything, especially if you're going to autoclave it. I'm going to talk about autoclaving in a future slide. All glasses, all glass waste has to go into the blue glass waste container, okay? Not the biohazard. So if you have bacteria on some glass that breaks, it becomes your responsibility to decontaminate that glass and then put it in the glass waste. When you autoclave dry materials, you prepare them for autoclaving. You actually don't run autoclaves here. We're really lucky. The lab kitchen does all of our autoclaving for us. But you still have to get it ready. So know that you need to use an autoclavable tub and pan, that if you use a regular plastic pan, it just melts in the autoclave. It's a mess. Make sure that you use indicator tape. That is a pressure reader, and it says that the autoclave ran a proper cycle and that your materials are sterile. Put that tape on the aluminum foil so that it's easy to remove. You put it to the glass, that adhesive really sticks, that the foil comes off. Lids are always on loose, okay? Always, always. You don't want it tight like this or it'll just collapse. So always reverse it a little bit so that the air can travel in and out when it's under that high pressure. When you autoclave liquids, you may not fill it to the top. You filled it to here, you'd end up with it to about here, and who would know what the concentration of this solution would be? So you'll notice all flasks tend to have a little line on them. That's pretty much the fill. It's just beyond half. Okay, items are placed in the tub with a small amount of water, and I can't tell you, because learn from my own mistakes. I worked in a lab for a long, long time before I assumed this job. If you just put your concave flask into that tub, it'll have an air bubble, and that bubble will be boiling and really threatening the integrity of your glass. So you just put it in that tub of water by burping it. Just by like that, the air will come out from here, and it will safely autoclave. All right? Liquid nitrogen is super cold. And when you use liquid nitrogen, don't wear just your nitrile or latex gloves. Make sure that you wear these insulated gloves, okay? Make sure that when you work with liquid nitrogen, you're using the proper material. If your laboratory doesn't have one of these can be shared with all the labs. Not all the labs have, but we all share. So find a lab that has it and borrow it if you need to transport your liquid nitrogen. Make sure when you're using something like liquid nitrogen, you have eye protection on, as well as those gloves, because if you were to splash in your eye, especially, your eye would be burned. So please be very careful. Thermocol is just not strong enough to hold the super cold liquid nitrogen. Likewise, when you work with dry ice, you really need to wear safety glasses, especially because most of us, when we work with dry ice, we're trying to break it up into little pieces for our tubes to fit in. And those little shards could come into our eye. So wear eye protection. Use the proper container. And don't put it on the countertop or in the sink, because the dry ice is so cold, it will cause it to crack. The most important thing you can do working in the laboratory is to wash your hands. Wash your hands before you start work, so that you don't bring anything from the outside into your experiment unexpectedly. And of course, wash them when you're done, so that you don't bring your experiment to the rest of your life. Glove etiquette. Gloves may not be worn. Oh no. Well, I know. Gloves cannot be worn when you open the door, when you talk on your cell phone, when you work on a keyboard, with the exception of ethidium bromide. If you're using the gel dock system with ethidium bromide, the positive ethidium bromide gel dock system, then gloves are required because the ethidium is so insidious it spreads everywhere. And the gloves that are near the ethidium, that if you've worn it there at the gel dock, those gloves do not go into the red biohazard waste like every other glove you wear. They will go into the ethidium bromide waste. So when you wear gloves, I'd like to demonstrate the safest way to remove them. Now this was a new box, and now I can't even get my hands into the glove. So, when you're wearing gloves, what's really important is that they fit better than this pair. This is just for demonstration purposes. And you should know the difference between a nitrile glove and a latex glove. Nitrile is much less permeable than latex. So depending on what you're doing, like with chemicals, you'll want them less permeable. When you're working with animals where you need really fine contact, like when you're handling mice, often you'll need to use the latex just so you can do the fine motor skills that are required with a mouse. So you do it appropriate to your experiments. But to remove it, you're going to pinch here at the top where there should be the least amount of chemical and whatever. Gently ball your hand and pull it off. Take this, put it into the opposite hand, and once again, see, I'm not even touching it, I'm just going underneath and pulling it out. Where will these very clean gloves go now? Where will I throw these after class? Red biohazard. Excellent. That's right. All gloves, with the exception of the ethidium gloves, will go into the red biohazard waste. So you may not wear your gloves when you walk across our campus. And you may not leave them on your bench. You can put them in your drawer if you have a drawer that's yours, put them in the drawer. But gloves that are left out in public, they're just assumed to be very dirty, and they really belong in the biohazard waste. Okay? Do you have any questions? Be sure you clean it before and after use. Clean up after yourself, leaving it cleaner than you discovered. And when you go to another lab to borrow their piece of equipment, because many of us share equipments here, you need to bring every single item with you. If you need a pipette pen, you bring it. So you'll have a tub with all your stuff, including your gloves, inside that when you go use another piece of equipment. Make a big list, a checklist, so that you know what you need. When you're using the last of something, make sure that the people in your lab know that it's running low and or you used the last of it so it can be replaced. You're all brand new here. you wouldn't know how to replace it. So it's time that you learn, but it is your responsibility to tell people when you've done that. Don't wear your gloves beyond the workbench. And please don't come to work when you're sick. You can come to work and go to the medical center. Do you all know where the medical center is? Mm-hmm. So, quick orientation. The main building where reception is, that's the Eastern Labs. And attached to that is the administration block, which is where you'll find me located. This big complex that we're in, this is the Southern Lab Complex. And then if you were to walk along here in the back gate, and there's the pond over to your right, and you just keep going that way, heading west, you'll come to our medical center, and that's where it's located. Also be aware that you share your air. It's very obvious here in the Southern Labs because it's a huge open lab space. So obviously, if you're working with something stinky like beta-ethanol or acetic acid and acetone, all those things need to be done in the fume hood. But what you don't realize in the Eastern Labs is often your laboratory shares an air conditioning unit with another lab. So you too are responsible for working with anything that produces toxic fumes in the fume hood. But I also want you to be aware that all fume hoods here so far do not have UPS to them. So when the power goes off, all that air is going to come rushing back at you. Pull the sash down. If the power clicks for even a moment, drop that sash. You're going to be transporting samples here. No doubt, as you have to go from one lab to the next, so you have to be thoughtful about where you are going. You may not take your samples through the canteen. You should not walk between the creche or dolna, which is across from the canteen, and the canteen, because we don't want the children exposed to you the scientific stuff you're walking around with, and they're supposed to be there. You just take a longer route. But just be thoughtful as you go around our campus that you're taking a safe route. And if you have any questions, you can contact me or the safety committee. We're all here to help you have a very safe experience. Here, I want to compliment this gentleman who was walking on campus, and it was after I'd seen a whole bunch of infractions. And look at this, a nice tub. He's got it, his gloves here on the side. So he's got everything labeled, and he's carrying the gloves in the tub. That's what we expect all of you to do. The MSDS, the Materials Safety Data Sheet, comes with every chemical. This one is sodium chloride, but notice it's still, 3 pages long. They all have the same format. But if you have a harmful chemical, it's really essential because it tells you how long to flush. For example, did you spill it on your skin? Did you spill it in your eye? Did you accidentally ingest it? All the protocol for how to take care of that mess is here in the MSDS. These we require hard copy. This is a notebook here on our laboratory, I'm pleased to report. Your lab should have them alphabetically. You do not need to keep sodium chloride there, but anything that says, with potential harm to your users, you need to have the hard copy. Every chemical that has a hazard has these symbols that I had up when you walked in. You should be aware of that and think about how to store like chemicals together, keeping them far apart. And in particular, acid and bases should not be interspersed. If you don't have separate cabinets, you are going to keep them clustered together, acids one place, bases, and they need to be on the lowest shelf. Because if you fall from a high shelf, it's going to splash your whole body as it comes to the ground. If it falls just from the lowest shelf, only your feet will be splashed by the harmful chemicals. So keep that in mind. When you open a bottle, you need to label it with the date and your initials. All the solutions you make need to be identified. What is the solution? What is its concentration? As well as the date and your name. When you weigh out your chemical, be sure you're using clean weigh boats and papers. Don't just tear up a random piece of paper because you won't know what's on that paper. Store your acids, bases, solvents separately if possible, but clustered and far apart from each other if required. Depends on how your laboratory is structured. Cleaning and recycling. If you want that bottle washed because for some reason you need it for, say, waste, many of us have to recycle, it's your job to clean out whatever's in it first. Lab kitchen here is not trained to the level of chemistry that all of you come in with. So you need to rinse out that bottle at least 3 times and let it air dry before you give it to our lab kitchen for cleaning. Chemical spills. Spill kits are available at stores. They come in different packaging. They all contain pretty much the same thing. Some have a little bit more or less of the same things. This spill kit is nice because it has this nice worm of absorbent material, so you can call attention to the spill that you've encountered. So most people would not naturally stand into this. So the first thing you want to do is isolate that spill and call for help. This does not mean that you walk away after you call for help. It means that you learn how to clean up your spill. So the seniors in your lab can help you with this. And if it's during normal working hours, call the lab support office. And you will get help from them. That help is not meaning that they do it. They make sure that you do it safely, but you will be responsible. Inside the lab safety spill kit here, the chemical spill kit, is lots of absorbent material, as well as some safety items like heavy-duty gloves, safety goggles, and a mask. Okay? Be sure you're wearing your lab coat when you do this. And just be sure that you don't do this alone. You should never work in a laboratory alone, ever. You really need to make sure that somebody knows you're in it, even if you're in a space where, like, say, we're a microscope and it's late at night. Make sure other people are around and know where you are and what kind of work you're doing as a safety precaution. So, if you have a spill that's flammable, turn off the power in case there's a spark you don't want to have it go up. You can call your lab seniors in Ranjit in the lab support office for help. And you need to file an incident report. These incident and accident report forms are available online and also through the lab support office. This will not get you in trouble. This will get you proper medical care. So we need to know when you have a spill, what spilled and what you've already done to keep yourself safe, and then we need to learn what we may need to do further to make sure that you've got the proper safety. Okay, and also, I'll probably want to talk to you and say, what did you do? How did it happen? How should we teach lab safety differently so that this doesn't ever happen again? So be confident that you don't get in trouble other than what the chemical itself might do to you. But we're not going to be, mad at you for that. If you get a chemical spill on your body, be sure you know where your eye wash station is before you have to need it, as well as the full body showers. So look around you, ask the lab seniors, learn how they operate before you leave it. That's why I passed around that fire blanket. It's so that you felt what? You see how it's supposed to operate so that it won't be a surprise if you ever need to use it. Flushing times for chemical exposure to your body are discussed in the MSDS that you will all have. And like I said, accident report form. Ethynium bromide, many of you will use it. We're really encouraging all scientists to switch and use alternatives such as gel red, but there's many on the market. And so you're not putting yourself in harm's way of this very powerful mutagen. If it intercalates DNA, it's doing that to you as well as the DNA in your gel. Also, if you're working with ethynium bromide, you will be working with UV light, which can cause burns. So you want to wear eye protection and a face shield. So, like I said, UV radiation, use shielding. Be aware of other places where UV light is used. In particular, our hoods have UV light, the transilluminators, like I discussed from the last slide. But even our clean rooms and tissue culture rooms, we have them there as well. You should know how those lights operate. You should know how to notice if they've been turned on. Because if you have regular bright light on and the UV light comes on, you may not notice that it's on. So I know here in the southern labs, we have like a red light that comes on if the UV light is on. So people know just by the red light's presence, oh, the UV light's on. So don't get UV exposure. You might work with SDS paste gels, meaning that you're working with some bisacrylamide. Acrylamide is a very powerful neurotoxin, so be aware of that when you're using it. You must polymerize all acrylamide before you dispose of it. If you don't know how to polymerize it, you don't have any business working with the acrylamide. See me. Okay? Also be sure you realize when you're staining and destaining how to get rid of and or recycle those components of your gels. This is a 10-minute video. I've never seen anyone that's this thorough. It's a nice introduction if you haven't worked in a laboratory, just to get a feel for how to work effectively. So let me know if the sound's going to work for you.
This video promotes chemical safety.
Louder?
One protocol is used to demonstrate the safety principles that apply to working with many of the hazardous chemicals used in the modern biology laboratory. It is intended to supplement the formal instruction provided in each institution and each laboratory. This video is not a substitute for a safety training program. The tools of the modern biology laboratory include an arsenal of chemicals. Knowledge of these substances and respect for the potential hazards will allow the research laboratory worker to practice good science safely.
You know, people who start in the lab have the tendency of being extremely concerned with radioactivity. This is really what they are scared of. Phenol and acids and all that, they are not too concerned about because we know exactly what happens if you put acid on your hand. But I tend to think that these are actually much more dangerous for the kind of research that we do, where we use low levels of radioactivity most of the time. And that these are the accidents one should really watch for, actually.
Where and how you perform a procedure should be determined by an understanding of the task at hand and the chemicals involved. This morning, Gretchen Hannon is going to prepare a series of DNA samples using phenylchloroform extraction and ethanol precipitation. Her first step is to equilibrate the phenol. The material safety data sheet is a good source of information about a chemical's hazards. Laboratory workers should be familiar with the relevant ones. The MSDS for phenol tells us it is a powerful corrosive and causes serious burns on contact with skin. Gretchen makes sure the phenol is at room temperature before melting it. She also allows for heat expansion in the bottle. Gretchen knows not to put the warm phenol bottle on a cold surface because the glass could crack and allow the phenol to run out. The MSDS for tris hydrochloride tells us it may cause irritation of the skin and eyes. Here's an opportunity to avoid splashes. Whenever hazardous chemicals are used, a lab coat, gloves, and safety glasses provide valuable protection. Be alert for the possibility of the stir bar cracking the bottle. A secondary container provides cheap insurance. Phenol is one of the more hazardous substances in the modern biology laboratory. Always consider safer substitute protocols as they are developed. To reduce risk of exposure, Gretchen avoids working with a large bottle of equilibrated phenol by preparing several small stock tubes. When you work with a chemical, consider whether you are doing anything such as heating or combining with other substances that will increase its hazardous nature. Adding chloroform, for example, enhances the ability of phenol to penetrate the skin. Chloroform represents numerous health risks, including cancer and organ damage. It may be harmful by inhalation or skin absorption, and its effects are cumulative. Phenylchloroform extraction in large quantities is best handled in the fume hood because of the inhalation hazard. Gretchen has performed this procedure many times. Otherwise, a dry run would help identify problems she might encounter with the workspace, equipment selection and layout, and with her dexterity. Note how she holds the cap, as well as the tube, to prevent it from unscrewing. After drawing off the aqueous phase containing the DNA sample, the phenylchloroform goes into an appropriate waste container. Be aware of the splash hazard. With 2 or 3 phenylchloroform extractions, the samples are ready for precipitation of the DNA. Sodium acetate may cause skin and eye irritation on contact. Ethanol's principal hazard is its flammability. When using small volumes of phenylchloroform, it is acceptable to work at the bench. Still, the chemical hazards are real. Snapping of microfuge caps can produce splashing. Gretchen uses her hand to shield herself. And she firmly grasps the cap along with the tube while vortexing. Working with chemicals safely means doing all the things required for doing good science. Know your protocol. Execute procedures meticulously. Know your chemicals. Use smaller quantities of chemicals. Consider safer substitute protocols. Wear safety glasses, gloves, and a lab coat when handling hazardous chemicals. Avoid splash hazards. Use a fume hood when handling stock quantities of volatile hazardous chemicals. Be alert for hazardous situations. Use a healthy dose of common sense. Maintain concentration.
There is clearly a danger that just by habit, when we forget and when we become less and less careful. The other thing is that people should not work in the lab when they are exhausted. I mean, I love having people working late at night. That means they're really interested in what they are doing. But on the other hand, one reaches a point where one is just too tired to do an experiment properly. And that is bad for safety. That is also bad for the experiment.
Do you have any questions? I'm going to briefly talk to you about biological safety now. On our campus, we have levels BSL 1, 2, and now we have a 3 here in the Southern Labs that's under construction. In order to get permission to go into the higher levels of safety, you require all different kinds of training than what you're provided with today. And each facility has its own training protocols. Disinfectant should be 10% Clorox, which has sodium hypochlorite. If you choose to use the Robin brand of bleach, it has less sodium hypochlorite in it. And when I did the math quickly at Big Market one day. I realized that Clorox brand and Rodden really are equivalent in terms of price if you're weighing in how much effective chemicals in it, okay? Also, you can disinfect with 70% ethanol. More than that is actually less effective than having 70%. Be sure you wash your hands before and after, like we discussed at the beginning. Take off your gloves, throw them in the red biohazard waste. Many of you will be using our biosafety cabinet or hoods. You need to follow some rules when you are working in a hood. You should know how they work. They work by airflow. So if you have a whole mess of stuff in there, the airflow is disrupted and you're not going to get the safety feature. So when you come to a hood, the best thing you can do is remove everything and clean that hood with your 70% ethanol. Don't use bleach on any metal, it will corrode it, so use the 70% ethanol. And then use what you need only in that hood, okay? Don't let there be extra storage of anything in that hood. Also, you need to let the air run so that it gets filtered and cleaned before you start your work. So you turn on that fan, and you turn on the UV light, and then you leave for 5 to 30 minutes. It doesn't need to be more than that, depending on what's convenient for you, okay? So let's see what I might have forgotten. You turn it on. You don't need to leave UV on all the time. It actually will break down your plastics, by the way, that UV light. So that's one of the primary reasons. Don't put a bunch of stuff in like I told you. And this we talked about in the film, if you were listening to her, to plan your manipulations in advance. And this was really helpful for me. When I learned tissue culture, I discovered that I naturally wanted to put my hand across the top of my open plate. So doing dry runs for any experiment will only improve your outcome. So please consider that when you're doing your work. Once again, just like we discussed at the beginning, check for the leak-proof integrity of all the containers that you're using. Inspect them. Transport them. Always, even you saw in that lab video, did you notice how she put the bottle inside a beaker so if there was any breakage it was contained? You need to do the same. Try and avoid needles and syringes as much as you can because they require a lot more work on our end trying to dispose of them. When you work with your biologicals, you should do your decanting in the hood to avoid the aerosols inhaling those materials. Make sure that you remember how to use the hood like we just covered, disinfecting it, turning on the fan, running the UV light. Also, you should know how to dispose of, because many of you, if you even do any kind of bacterial work here, you'll use a centrifuge, pellet your bacteria, you'll have a nice pellet in your container, but all this extra liquid still contains some bacteria that needs to be decontaminated by you. That's when you use your 10% bleach. You're going to swirl it, you're going to let it sit for half an hour to make sure that the bleach has time to kill whatever bugs you have remaining in that supernate. Then you'll come to a sink and you'll start running that sink. It's a good idea to do that because what if the sink were clogged? You want to back it up with this bleach bacterial crap. So run it for a couple minutes, make sure that the sink is flowing, and then pour it directly down the drain because it's already just decontaminated by you. Rinse out your flask 3 times with water. Let the flask get to be washed. Any questions? Biological spills will be handled really very similarly in terms of if it spills on the ground as a chemical spill. If it's a big one, you want to isolate the area, get your help, and absorb it. The only difference is how you're going to dispose of it. In the case of a biological, you're going to get those in a double autoclave bag, double bag for autoclaving, and that has to be autoclaved. You won't do that to chemicals. That's usually a very bad idea. Wear your personal protection gear like I demonstrated earlier to you. Clean it up with 70% ethanol because bleach is so corrosive to most surfaces. Bag it up for autoclaving, and even with the biological spill, once again, use our accident report form, please, so that we make sure that you get the proper medical care and we avoid future spills. The same will be true when you have this happen to your body. You need to take off your clothes, so that's why you wear a lab coat. Then you only have to remove your lab coat. Wash the area with soap and water for at least a minute, but more depending on what you were handling. apply 70% ethanol, rinsing it thoroughly right away, okay? Get medical attention and fill out your accident report form. So it's kind of the same protocol in terms of getting help, filling out the forms, so we make sure you get the help you need. All of you should have read the lab safety manual, and in it we have all these different trash. So I don't cover this here, I only covered 2, but there are 12, and depending on what lab you work in, you might be using all 12 of them or 1 or 2 of them. This is a campus photo. What's wrong?
It's not closed.
Not only is it not closed, what's inside of it? Yes, this is not for regular trash. Your food trash does not go into biohazard. It's pretty unlikely the food you were eating is biohazardous. We tend to put a gray dustbin, which is the regular dustbin, close to the red one. So that, like, when you open up the packaging that's around your pipette tips, that plastic, which is clean, goes into the gray dustbin. But the tip that you use that has biologicals will end up in the red. Is that clear? So I want to briefly talk to you. We have a lot of support on this campus, which makes doing science here fun and a lot less of a hassle for all of us that partake. We have the lab support office that I'm going to talk to you about, and we have instrumentation that I'm going to talk to you about. Also realize that we have all these other support facilities and offices that help you do your science. The instrumentation department has many responsibilities. As you've noticed today, they've helped me a lot with my connection. But they maintain all of our instruments and common equipment. They provide training to us for the equipments. They also give us the multimedia support that you were demonstrated today. They help you with your phone doesn't work. They also provide access control, which most of you shouldn't be having until you pass the safety exam today. You can contact them at instrumentation at NCES. You have responsibilities when you use our equipment here. You have to be supervised by experienced users. You need to go through training. You should read the manual so you know how the machine is supposed to operate. You must sign in and sign out on the logbook, as well as on the online scheduler. This is big. I'm coming to a whole slide on this. And you may not move the equipment. There are infractions. If you break these rules, the consequences are big and can be terminating your career here. So the online scheduler is online, and it's your reservation. It tells us that you're using the equipment, and it tells you when it's available for you to use. You have to use that. Next to all the equipment, we have a logbook. The logbook serves 2 functions. One function is so that instrumentation knows how much the equipment's used, so it can get it servicing when it's required. It also tells me that you're using it. So if something happens and your sample goes flying out of the machine or whatever, all these unexpected things, your name and phone number's there, and I can call you and say, hey, the power went out, the PCR machine is stopped, what do you want to do? So that logbook is vital. If you don't follow these rules and it's common equipment in the southern labs, I throw away your sample. And as much as I teach this once a year is my average, I have to throw away a sample, and then you all become the effective teacher. Because when your sample gets thrown away, everyone here realizes that this is a serious rule with consequences, and it gets followed for a very long time. But it does have to happen, so don't let it be you. Also, if you damage equipment from negligence because you weren't properly trained and you just decided to do it your own way, your PI can be held financially responsible for the damage you create. This can also terminate your career. You need to coordinate the repairs through our instrumentation team. Because they know about safety, they need to know about the equipment that's broken, and in addition, they know how to get safety when something happens. And this brings me to the mercury spill kit. The mercury spill kit is kept at reception, and it's kept on the first floor here in the Southern Labs, next to the chemical spill kits, which are kept where our fume hoods are, on the first floor. Why did this tie into the vendor? Well, we had a vendor that came to CCAMP. CCAMP was mercury-free. It turned out the vendor had equipment that was not mercury-free, and he broke it. they didn't have a spill kit there because, of course, they were mercury-free. But by working through instrumentation knows the location of these, and they can help this happen. They can also prevent these things from happening. So do coordinate all your repairs through our instrumentation department. Centrifuge safety. I hope all of you noticed when you came in, because I have props here just to keep you entertained while you're waiting, this lovely rotor, unusable. This is a campus rotor. This was from CCAMP. I've been told that what happened was, it was a Beckman rotor where somebody put a thermo bucket in. Really bad things happen if you don't know how to use a centrifuge. It's vital that you go through training. It's vital that people watch you use the centrifuge many times before everyone is confident and comfortable that you know what you're doing. They're very expensive. Even the rotors alone are expensive, much less the machine. So when you use a centrifuge, get help first. Be sure you know what you're doing. But you need to balance the tubes that you'll be putting in. You don't eyeball balance, use a scale balance. Okay? You also need to make sure that you balance them within the rotor. You can't put them cattywampus to each other and expect that core rotor to do the work. You also need to have a really good idea about how the rotor seats on a spindle and how the lid might be a vital component to seating it. Often the lid itself has to be tightened a certain way in order for that connection to occur to hold the rotor in space on the spindle. So make sure whenever you're doing centrifuge safety, you have help, because you're all new here. Also, you're going to learn about the innate point imbalance. When a centrifuge comes up to speed, it starts making noise. Is this the noise that you expect, or does this mean that you've loaded it incorrectly? The experienced person will know, but you're all new here. You won't know. Get help. Don't get help after you start it. Get help before you use it. Don't open a centrifuge before it's stopped running. You need to clean up all spills. The spill in the big tub, you put in towels. That's required. Even if you just use the refrigerated component, you don't have a spill in there, but all that ice that forms, that needs to be dried or it will corrode. So you always put a towel into the tub. All rotors need to be rinsed out and left upside down to dry. If you have a biological sample, though, you need to decontaminate it before you rinse it out. Okay. I'd like to show you pipette men. What's really important about pipette men when you use them is that you have some practice before you're really doing experiments that matter. It's very important that you learn how to seat it. Most of us never actually just kind of go like this gently. You'll pretty much hear that little, most people make sure that there's a nice tight seal. That helps the probability that you're going to pull up the right point. You need to learn to be very comfortable with the different stops on the pipetter so that you know how to operate it. You also need to use good judgment, like we talked about in the movie, where you look at the volume. Every measurement you take, you will save yourself hours of heartbreak. If you just look, because you're going to know a half a microliter from 1 microliter from 10 to 100. You will know this with practice. So before you have to do a real experiment, play with water. Learn how to operate this. Those dry runs really save you in the long run. So please learn how to do that. We have a lab support office, and they have a lot of responsibilities that help us. They dispose of all of our chemicals and all the old equipment. They manage our lab kitchen, which will be a whole other slide to tell you what they do. They take care of all of our consolidated orders, oligonucleotide orders, and also our facilities, the CPAP facilities. They facilitate all that. They stock our lab gases, and you can reach them at lab support. Like I mentioned, under our lab support office is the lab kitchen. They clean our glassware, they do all of our autoclaving, they distribute the water, they distill our alcohol, they clean up our common lab areas because we don't have the kitchen, the regular housekeeping does not come in the laboratory, it's the lab kitchen people who have a little more training than do. They maintain our tissue culture laboratories, they take care of all of our waste collection and disposal, and you can reach them directly at Lab Kitchen. I can't emphasize enough the importance of you filling out the accident report form. We've talked about it a few times, but I want you just to know that you really should feel very comfortable and confident about this piece of paper. So I've completed the class. I'm going to tell you again, if you were here early you heard this, and if not, I'm going to tell you latecomers. I'm going to give you a test with 30 questions, and you're required to get 80% of it right. 10% typically fail. No one has ever failed without following. You must answer one answer for multiple choice, and multiple answer will have more than one answer. Okay? Now, if you forget this rule, it's written on the exam, and every question tells you whether it's going to be multiple choice or multiple answer. So just review your question types before you turn in the test. It'll increase your chances. I'm going to email you results. If you did not email me and register for this class, then you will not get an email from me. But if you did, then you'll hear back from me tomorrow, and I'll tell you when to meet me and where. And I'll tell you where I'm located, but I'm going to kind of describe, because I'm thinking many of you are new here. I'm in the administration building, which is the furthermost north building on the 3rd floor next to a chauffeur in the administration office, or establishment office. It's known as both. Okay? If you work in the southern labs, do try catch Bhumika sometime. I introduced her at the beginning because she can show you the location of the showers and show you how the eye washes work. So if you ever have any doubts, contact Bhumika. And be sure that you're going to attend the campus ethics orientation. That will be offered at 4:30 today, right here. So you have until 4:30 to take this exam. And if you're done early, you can leave, but come back by 4:30 and then stay for ethics. When you pass the class and you come see me, I have the certificate of participation that indicates that you passed. And this piece of paper you will show, depending on which institute you work at, to the CBS in Ramprasad, Instant Shova, and this will activate your access card and any fellowships you might have. Do you have any questions?
Is there negative mark?
No, yeah, questions right or wrong, and if you guess, it's just going to be wrong, but you don't miss the mark.
I have a question.
Yes.
If somebody claims that one liquid nitrogen box is fallen into a 100-liter liquid nitrogen container, what is the correct way to take the box off?
You call lab support. They've done this recently. I don't remember. Do you remember what were you there? Ranjit, yeah, Ranjit and lab support. They figured out how to do this. I don't remember. And what happened in that big door, because it was a big door, what I remember happened, and it was a container like this size, and it turns out there's almost like this little bubble inside it, and it had gone underneath and in. So the whole thing had to be emptied out in order to get this out. But the lab support office, Ranjit in particular, knows that procedure. I just heard about it, so I'm just telling you what I heard.
I faced this incident, so that's the reason why I was asking.
Yeah.
I saw that people were taking out liquid nitrogen in thermocol boxes.
Huh. Yeah.
So, and I don't know.
If you
is the
see that
same
happening,
procedure,
if that's happening on our campus, you should call.
on campus.
On our campus, then you should call me or Ranjit in the lab support office so that we can come and get people to follow the rules. If they don't want to listen to you, just call us right away. Our mobile phones are listed on the calendars that we give out, so you can reach us, like immediately with our mobiles. Or you can call our offices too, of course. But often we're usually walking around our campus, so you'll have to find us more by mobile than in our office. Other questions?